Welcome back to Math with Patrick. Today is June 8th, and we're solving problem number 159 from this Daily Epsilon calendar. And we need to show how many pairs of primes sum to the number 102. So over on the right side of the screen, I have all the numbers from 2 to 100. And I'm going to use a strategy called the sieve of Eratosthenes to find out all the primes that I'll need for today's problem. Essentially, the way it goes is you just start at the first number you see, and if it's not crossed off yet, it's prime. So 2 is prime. And then now I'm going to cross off all the multiples of 2. So like 4, 6, 8, 10, all the way up until however far I want to go. And I'm pretty sure up until 100 is totally fine for today. And so I'm just going to be a bit quick and just draw these vertical lines because all of these numbers are going to be the even numbers between 2 and 100. And we're just going to continue through this process until we can stop. So 3 is the next number, not crossed off yet, so it's prime. And then I'll cross off all the multiples of 3, so like 6, 9, 12, 15. And at least in this table, when you do like a 10 by 10 grid, the multiples of 3 show up in these diagonal lines. So I'm like kind of starting top left, going across, and I'll just cross off all of these diagonals so I can cross off all of the multiples of 3. And I think it'll probably be easiest to now start on the right side because I can just kind of see that like 30, 60, and then 90 are all going to be pretty easy multiples of 3 to find. And I think that's all of them. All right, so we're going to skip 4 because it's crossed out. It is a multiple of 2. That's why I crossed it off. So 5 is the next prime. I should cross off all the multiples of 5. All the 10s are done. So it's just this column with all the numbers ending in 5 that are going to be my other multiples that I haven't crossed off yet. 7 is the next one. I don't think there's an easy pattern here, so I'll just count up by my 7s. So 7, 14, 21. Oh, and it kind of makes sense. So 14 is already crossed off because that's 7 times 2. 21 is already crossed off. That's 7 times 3. 28 is already crossed off because that's a 7 times 2 times 2. So really the first 7 that's going to be new and important to cross off is 7 times itself, 7 times 7. So 49 is the first number. Where is it? There it is. This is the first number that I'm going to cross off due to the 7. And I should keep going from here, though, because maybe there's other numbers, other multiples of 7 that I haven't crossed off yet. So 56, I got. 63, I got. 70, I got. And then 77, there's another one. 84 is even. 91, I didn't do yet, so let's cross off the 91. And 98 is even, so I already got that. All right, 8 and 9 and 10 are composite. That means 11 is my next prime number. And using the same logic about that 7, where like 49 was the first number that I needed to think about, the first number that I need to think about for 11 is going to be 11 squared, which is 121, which is off the grid. So any prime number I circle now, I won't need to cross off any numbers because the first one I'll need to cross off is, somewhere down here. And that means all remaining uncrossed off and uncircled numbers are prime. So all of these ones are going to be the prime numbers. So the sieve of Eratosthenes is like pretty good, pretty efficient for like small numbers. Like I only needed to really check up until 11, like barely over a tenth of the way to 100. And I was able to figure out all the primes all the way up until 100. Honestly, even past that, right? Because I could keep circling numbers up until 121 and still be pretty safe. But once you get to like larger numbers, though, to like find primes, you're going to need like better strategies in this because it isn't the most computationally efficient, like for computers with really large numbers. Anyways, what we can do now is look at our list and try to figure out what primes sum to 102. Like if I tried looking kind of here, 2 is my first prime number, 2 plus 100 gives me 102, but 100 isn't prime. So I'm going to cross that one off. And I'm basically looking like sequentially through my list. So 2 and 100 didn't work because 100 is composite. 3 and 99 is not going to work because 99 is composite. So I think 5 and 97 is our first pair, right? Because once I add these two, I get 102. And you know what? Maybe I'll actually count from the bottom. The prime numbers are more sparse down here, and so I'll run into fewer primes and I'll have to check fewer conditions if I just start from the bottom. So the next prime that I want to check is 89. And then if we do, 102 minus 89, that is going to be 13, I believe. I'm like kind of counting up in my head. I'm doing 2 plus 11, yeah, which is 13. Cool. So 89 lines up nicely with 13, and that's another prime pair. If I subtract 6 from 89, I get 83. And if I add 6 to 13, I get 19, and that's another prime pair. I like this method too. If I go minus 4, I can try to add 4. Ooh, cool. 1, 2, 3, 4. And then 1, 2, 3, 4. So here's another prime pair. 1, 2, 3, 4, 5, 6, 7, 8. And so if I add 8 to 23, I get 31. Nice. This is a fun method to like just kind of like skip count essentially. I will go minus 4 down here. So plus 4 doesn't work because that would give me a 35. So I'll at least cross off this and this just to kind of keep track of where I am. I can go minus 6 to get to 61. I was at 4 or 35 earlier, so plus 6 will give me this pair, 61 and 41. Those do indeed add up to 102. That's cool. And let's see, minus 2 and plus 2, ooh, these also give me another pair. And then lastly, looks like the 47 and the 53 won't work out together because they'll add up to 100. And so kind of looking outwards in, this is the last pair of primes to check, and it didn't work. So I think if I just circle all the primes up, or the green circled primes up until this 47 and count them all, I should get 8. So I'm going to look at these ones, and I have 1, 2, 3, 4, 5, 6, 7. That's not 8. Maybe I missed a prime pair somewhere. Like I'm looking over all of these numbers and they're either crossed off or circled. Oh, okay. 73, I did not circle. Whoops. Okay, so 73 is prime by the sieve of Eratosthenes. And if I do 102 minus 73, there we go. Okay, that's going to give me the last prime of the list, 29. This should have been a green circled prime. And there we go. Now we have our 8 pairs. Okay, cool. That confirms it. There are 8 pairs of primes that sum to 102. This problem is related to Goldbach's conjecture, and so I recommend looking that up and kind of investigating if you feel like it. It's all about adding 2 primes and getting to some even numbers. Currently, the best guess is that you can do it for any even number you want, 4 and higher, though no one really knows. It's one of those like unsolved problems in math. So I recommend looking that up because it relates to today's problem. Anyhow, we're all done. The answer was 8. I'll see you tomorrow. Bye.